Now that our wafer has a thin, flat layer of photoresist on it, we're ready to place it against the mask pattern and shine light through to the wafer. This machine you see me working on is called a mask aligner, and we're going to use it to hold the mask and the wafer very close to each other and very steady and stable so that the pattern ends up sharp and crisp and so that nothing gets damaged, so that the mask and the wafer don't get scratched or damaged in any way. The mask aligner has a special light in it that's very high energy, and it's going to cause a strong reaction with the photoresist when it shines through the transparent mask areas and onto the wafer photoresist. You'll see that this light appears blue and very bright, which is different from the light that's in the room. You may have noticed that the ceiling lights in the room are all yellow. Did you wonder why this is? It's because the yellow light in the room is much softer and lower energy, and it won't cause a reaction with the photoresist that we're working with. So this lets us spin photoresist onto our wafer and work with it out in the open in the yellow light without worrying about causing any accidental reactions. When we're ready to cause the chemical reactions in the photoresist, we'll put the wafer in the mask aligner, and the reactions will only take place when the blue light is shining. So we use the yellow light in this room basically the same way that red light is used in a photography darkroom. So now you can see the mask close up. It's basically a 6-inch square of glass that has some metal patterns drawn on it very carefully. We want to be extra careful that there's no dust on it and that we don't scratch or damage the mask when we put it into the machine. This is because masks are very expensive and they take a long time to make. So I make sure to blow off any dust from the mat that might be on the mask with a nitrogen gun, and I make sure to wipe off the mask holder before I put the mask down. The holder has a special vacuum in it that's going to hold the mask upside down and will keep it from falling down when we put it upside down. Our wafer goes on a different holder, a different chuck that lies underneath the mask, and initially the mask and the wafer aren't going to be touching. This will let us look through the mask and move the wafer around until the pattern on the mask is lined up with any other patterns that we might already have on the wafer. So you'll see this happening in a few steps, and it will make a lot more sense. Now the step where we align the new mask pattern to the other patterns on the wafer can actually take a really long time, and so we're going to speed the video up here. This is my friend Patrick, who's helping me do the mask alignment so that I can film what's going on while he's working. As you can see, there are several different sets of different shapes and patterns, and Patrick is working really hard to line them up all very carefully. Since the shapes are very small, it can be difficult to do, and it can take a while to get them all lined up because even the slightest shift or vibration in the machine can move things and knock things out of alignment. So this actually takes a long time. That's why we're speeding the video up here. But you can see Patrick lining up the different shapes that are on the wafer to the shapes that are on the mask. Once we're done lining everything up, then we tell the machine we're ready to shine the blue light through the mask pattern and onto the photoresist on the wafer. This step is called exposure, and we have to make sure to shine the light for just the right amount of time so that the pattern comes out crisp and sharp. If we shine the light for too little or too much time, the pattern can get fuzzy or it can get messed up, and we'll have to redo all the work we just did. So once the exposure is complete, we clean up the tool and we leave it nice and clean and ready for the next person to use.